Hey kids, what you've just seen is a demonstration of Newton's first law of motion. Alright? The first law of motion basically states that an object at rest will remain at rest unless acted upon by an unbalanced net force. An object in motion will remain in motion unless acted on by an unbalanced net force. Alright, we take a log, we put it here on our splitting block, right? We get that guy balanced. We've got two forces acting on this right now, and they are balanced forces. We've got gravity pulling down on the mass of this block, right? This piece of firewood. We've got the log itself, or the chopping block, right, pushing back up. So this thing is going to stay there, right? It's got balanced forces. Gravity pulling down, the log pushing up. It's going to stay in that position until acted on by an outside force. All right, so let's demonstrate an outside force. All right, not too shabby. All right, guys, so we also saw we can explain Newton's second law of motion. Okay, the acceleration of an object depends directly on the net force applied to the object and inversely on the mass of the object. All right, so let's say I take a small piece of wood and I put it on here. Okay, take a small piece of wood and I put it on there. If I were just to hit it, kind of like a baseball with my splitting maul, right? Its acceleration is going to be equal to the amount of force I hit it with divided by the mass of the piece of wood that I hit. Okay? Now, this log is a little bigger. Not a whole lot, but it's a little bigger. More mass. All right? Let's say I hit it with the same force. Okay. Now, I don't know if you can see where it went, but it didn't go nearly as far as the first one. All right. Maybe I didn't hit it quite as hard. Not sure. But Newton's second law of motion says that acceleration of an object depends directly on the net force applied to the object and inversely on the mass of the object. Okay. So if I hit two different objects with the same force, the lighter object is going to accelerate faster. Okay. The heavier object, because the mass is on the bottom, will accelerate slower. All right. Now, remember, this is the net force. We can put a log on there. If it's balanced forces, all right, we've got, well, if I can get it balanced. That's not balanced. Let's try this one. All right. If I balance that guy, there are two forces acting on it, but they're balanced, right? I've got gravity pulling down, I've got the stump pushing up. No acceleration, right? Because the net force acting in equal opposite directions is zero. All right, so that log's not going to go anywhere. But again, if I were to hit it like a baseball, right, it's going to go somewhere. Okay, let's also talk about Newton's third law of motion. For every action force, there's an equal and opposite reaction force. Okay, you might say, well, what does that mean, Mr. Holmes? Let's show you. All right. We put another piece of wood on our chopping block, right? And again, gravity's pulling down, this guy's pushing up, okay? This piece of firewood is exerting a force on that, right? It just happens to be equal to the weight. It's mass of this wood times acceleration of gravity. I don't have a scale out here, so I don't have any way to really measure it. I don't know, 5 pounds, 8 pounds, something like that, maybe 10. Okay? So you take its mass times the acceleration of gravity. That is the force that this is pushing down on the block. There's an equal and opposite reaction force pushing up. Okay? So this is applying a force to the chopping block. The chopping block is providing equal and opposite reaction force to this guy. All right? They weren't equal and opposite, something funky would be happening. Okay? All right. Important thing to realize with Newton's third law of motion, that the action force and the reaction force occur on different objects. Okay? The action force and the reaction force occur on different objects. So this guy, let's say he's doing the action on that one. This guy's doing the reaction. He's applying a force to that one. right? And the same thing happens if I use the maul. I hit this. When I hit it, okay, the maul is applying an action force to the wood, and the wood is hitting back, right? It's hitting the maul in return, right? Now, that's why we feel, right, the vibration of the impact applies a force backwards, or back, right? The force hitting and the force returning are equal and opposite. Okay, they don't behave the same way though, do they? This object slows down after I hit the wood, and this object splits apart. Okay? Alright. One other thing we should say, you guys are all familiar with mauls, right? They're basically shaped like this. You got a nice wedge shape here. Okay, a wedge is really a simple machine. Alright? A wedge is a simple machine. What it does is two inclined planes touching each other. As you hit the wood, it pushes out, right? So it changes a force going this way into a force going outwards, okay? In both directions, outwards. Now, a splitting maul is actually a compound machine because it's got the simple machine of this plus the simple machine of the lever arm, all right? Those two things together make a compound machine. Anytime you combine two different simple machines, you get a compound machine. It makes it much easier to split wood using this, right? This maul. And if I were to take, say, just a splitting wedge, right, and try to split the wood by hand, this is going to be really unsafe and not effective, right? I could be out here all day long chopping that wood and probably not getting anywhere. But we break out the compound machine, we get the advantage of the lever, right? It's be a, I think, class 3 lever, and the inclined plane. Okay, so let's recap. We've got a piece of firewood sitting on my chopping block, right? Newton's first law of motion tells us, basically the law of inertia is another name for it, that an object at rest will remain at rest until acted on by an outside force. Okay, an unbalanced force. Right now there's gravity pulling down, block pushing up, balanced forces. That guy's not moving right now. Okay, we go ahead and hit it with a splitting maul. Suddenly we can produce motion, right? Because then the forces are no longer balanced. Even if I hit it straight down, right? Didn't hit it very hard. But hit it straight down, split it apart, right? Create an unbalanced force. All right. So that's Newton's first law. What's Newton's second law? Well, I still have it on this board, so I'll show you. Second law says the acceleration of an object depends directly on the force applied, right? So if I hit it harder, it's going to accelerate faster. If I hit it softer, it'll accelerate less. But inversely on the mass of the object. So if the mass is less, right, the same amount of force will cause a greater acceleration than if the mass is more. Okay, makes pretty much sense. Kick a soccer ball sometimes, see how far it goes, and kick a bowling ball, right? See how far it goes. Okay, you can hit just as hard each time. First time the soccer ball will go flying, second time you'll probably go to the hospital, check your foot out, see if it's broken or not, all right? Okay, and then Newton's third law of motion. For every action force, there's an equal and opposite reaction force, right? When I hit that piece of wood, that wood hits back, right? You can feel the vibration in the handle. So if I hit that piece of wood, the wood hits back, and okay, the amount of force I apply to that block gets applied back. Why do they act differently? Well, this has a different mass, right? Different momentum than this guy. This guy has no momentum when he's sitting there still. All right, so that's a big factor. Also, this is a different mass, right? Another thing, this wedge is going to change the direction of the force. Right, it's one thing an inclined plane does. I'm going to swing straight down. The wedge is going to apply the force outwards, right? As the tip pushes down, the wedge pushes outwards. That's what causes the wood to split. All right, I hope this video was helpful, and maybe you learned a little something. Thanks.